Right, so we need to find the product here in this particular type of chemical reaction in organic chemistry. And we look at this with much caution and we present the solution. So the couple of things we need to first take note of. The fact that we are actually reacting an alkene together with um, a hydrogen bromide. And so this reaction itself constitutes what we call the hydrohalogenation. And the solution is as follows. So we present the solution right now. Right, so we start with hydrogen, another hydrogen, the double bond. Then you have hydrogen. Then you have hydrogen, hydrogen, hydrogen. Okay, it reacts with hydrogen bromide. And in this chemical reaction, what we're able to achieve is that the hydrogen in the hydrogen bromide will actually be such that it will be attached to the hydrogen that has the most hydrogen atoms. And so, or the hydrogen that is the largest number of hydrogen atoms across the double bond. And that will then give us the following, right? So it will then give us hydrogen, like so. And so you'll then have here hydrogen. So if these are the two hydrogens, then this hydrogen from the hydrogen bromide will therefore sit like here. And after it's set there, then you have, right, this particular carbon atom that is going to be bonded to the other atom from the hydrogen bromide. It's going to be bonded to the bromine atom. And you have Br, like so. And with that said, then we continue and we bond like so. Okay. And so what is the meaning of all this here? Right. So this becomes what we call the main product. And so let us write down the names. So first and foremost, this one is called propene. And this one here is called the hydrogen bromide. Hydrogen bromide. Okay, so this is called hydrogen bromide, and this is called propene, and the last one then is called 2-bromopropane. Right, it is called 2-bromopropane, like so. Okay, and this here is actually the main product. The main product of this particular chemical equation. Now, the fact that this hydrogen is bonded to the carbon on one side of the double bond with the most hydrogen atoms, so that's where this hydrogen is going to be bonded, is due to a result by the Russian scientist. Right, there is a result by the Russian scientist. Right, Russian scientist. This Russian scientist is called Vladimir. Right, Vladimir Markovnikov. Vladimir Markovnikov. Okay, so the Markovnikov's rule. The Markovnikov rule. Right, what does the Markovnikov's rule state? So it states as follows. During the addition of a hydrogen halide, HX, where the X represents either chlorine, bromine, or iodine, to an asymmetrical, right, asymmetrical alkane. Now, point one, the hydrogen atom bonds to the carbon atom with the most, right, with the most, or do not want to use the word with the most, use the word with larger number of hydrogen atoms, like so. Now, moreover, the X group, right, something called the X group, bonds to the carbon atom with the least hydrogen atoms. So that's what we have. That is what we have. So this is what I call Markovnikov's rule that we actually used in this case to analyze these and get the results. So in view of some of the most basic reactions that we can most certainly do, right, and this was a very easy example. Right, that's enough for now, and goodbye to you.